and welcome to SOLIDWORKS Skills video.
There's a whole set of features within SOLIDWORKS that pertain to the creation of sheet metal parts. They're often ignored. There's a sheet metal tab up here. If it isn't present, you can right-click and turn it on. Using sheet metal is quite different than machining solids out of a block of material. Sheet metal parts are created by bending and cutting and forming, impressing. There's many things you can do to it. There's a thing called expanded metal where you can create screening and other very lovely parts quite economically. If you are lucky enough to have a vendor or a shop where you can create sheet metal parts, and that would include cutting and bending, you may find that the parts are more economical, they're lighter, they're strong without welding, and there's some very nice features. So let's get started. Let's make some sheet metal parts. So I'll click on Base, Flange, or Tab. That's usually my starting point. We're going to create a small box, a four-sided box. So we'll create a corner rectangle. We'll dimension it, make it say 6 inches across and 2 inches from top to bottom. When you're creating a flange, you don't want it to be a closed shape. I'll trim away the bottom, and this will become the beginning of my cross section. I've done my trimming, finished the sketch, and you'll see that it comes right into the point where you can start creating a solid. You see how it by dragging the arrows you can create any depth you want. Frequently you work with stock materials that are, let's say if you're in America, you would use an American or an English gauge table, and you would choose a gauge that makes sense. Gauges, the number, as the gauge number goes up, the thickness of the metal goes down. So I'm going to choose a gauge, and you'll see that I'm given a default bend radii. You see how the corner has a radii. That's to prevent it from cracking and breaking. As I go higher in thickness, as in say the 12 gauge, the radii increases. If I go to a thinner gauge, the default is a smaller number, so you can choose what makes sense. I'll stick with a 14 gauge, and let's say for this example I want to go 4 inches, and I think I'm about ready. Let's accept that. So here I am with the beginning of my sheet metal part. Now, one of the beautiful features of SOLIDWORKS is that at any time, assuming you haven't violated what can be made with a single sheet of metal, you can flatten it to see what you would need when you walk out into the shop. This shows the flattened version of that. It also illustrates the lines where you would be doing your bending. So let's unflatten it and continue adding features to it. Let's go back into this base flange for a moment, because I want to show you something, an error that will affect you if you happen to want to create a box like this. Notice, for example, my 2-inch and my 6-inch dimension are on the inside of the box. That might not be what you want, so let's reverse the direction and we'll make that an outside dimension. That'll make life a little bit easier when I'm adding flanges to have them come up and mate. So I'll accept that. Let's create an edge flange on one edge. I'll pick a bottom vertex. Notice it's already starting to try to create it. I can choose the flange position. If I choose to bend it from here, that might cause cracking. It certainly is an unusual way to have a bend. More likely you want to have them not intersect each other, and that would be to use the bend outside as the flange position. You may also want to add a fillet to this corner. That's something a little more advanced. So let's continue. We do want a 90-degree bend. How far do we want it to go? Well, we'll go the same 2 inches that we went with the base flange. Let that finish. So now here we are with a three-sided box. Let's add a more interesting feature to the front edge, a miter flange. And you'll see what that does just in a moment. That'll be attached to this edge here, and there's a sketch plane that's created, and you'll see what that's for. We'll go into a line, and we're going to have the line emanate from this corner. We'll go straight down, let it snap, and we'll go in. Let's go up. So there's an interesting feature. And what are we going to do with that? Well, we're going to let it create a miter flange based on that line. And it has followed it. It uses the same parent material, the same bend radii, and if I accept that, you can see now I have this very interesting shape. If I want to see what it looks like in the flattened condition, I can always flatten it and open it up. Now it's showing me a few more bend lines. I'll unflatten it. Let's add one more feature to this and then we'll be done. We're going to add a hem to the three straight sides. So we'll add a hem here, here, and here. You might use this if you want to have, for example, a dish for birds to land on it, for a little feeder, for bird seed. I'll accept that, and here we have this lovely part. And like I said, if you have sheet metal capabilities, you could fashion this. It would be extremely strong and use a very efficient amount of metal. There'd be basically nothing you'd be throwing away except for whatever you might cut in these four corners. So it's quite efficient and an excellent way to design your parts. So let's move on to a little more complex way of creating sheet metal. An industry that has made great use of sheet metal is heating, ventilation, and air conditioning. Here's an example of a part, actually it's a simplified version of a part that they might use to transition from a circular duct to a more rectangular duct. And you'll see at the bottom here there's a gap that's intentional, because if I were to flatten this part, you can see how I can make this out of a single flat piece of sheet metal. There it is. You could die cut that or use other methods to cut it. You could even use sheet metal shears, and then you would come in and do a small bend along each of these lines, and you can see how those lines become the basis for what looks like a curve feature. It's actually a segmented curve. So let's go ahead and create this part. You'll see how using the Lofted Bend. So we'll create a new part. This is a fairly particular process, not one that is especially forgiving of error. So you may find yourself working on this one a little bit. Let's make it parallel to the front plane. And in fact, we'll make it coincident with the front plane. That'll be my starting point. So I'll draw, let's say, my circular feature on there. Let's create the other plane right now. It's out 16 inches from there, and that's good. So now I have the two planes that represent the location where my sketches will live. Let's create the first sketch. I'm working on the plane that's near me. We'll do a circle. Let's make it 10 inches in diameter. And now I will need to cut a notch in the bottom. Remember go back for a second. You can see how there's an opening at the bottom of both the rectangle and the circular feature, which allows this to be made from a single piece of sheet metal. So let's go back to our new part. We've just drawn the circle, and what I want to do is to create a rectangle that I'll use. Let's put it on this plane. A rectangle that will cut the notch away. I'll dimension it to begin with. Let's make it a 1/4 inch wide. That's good, and let's center it on the the center of this guy, of the circle itself, make it vertical, and now I'm ready to do some trimming. I could convert these into construction lines or delete it altogether. I think I will keep them so that I can change them later. I'll shift click on each of the lines, make them for construction, and now what I can do is to use a trim operation and cut away, and I'll leave that there. My circle is basically done, so I'll leave that alone, and that can form the beginning point for my lofted bend. Let's come around now, and we're going to create a rectangle that will be centered on that. Let's exit my original sketch. We're going to create a sketch on this plane, create a rectangular feature, and we'll accept that. I'm going to create a couple of I'll create a reference line, a center line, so that I can center that on the center of the circle. And what I'll do is I'll pick the center point of that and the center of the circle and make them coincident. So here we go. Those are now in alignment. Let's dimension this. I'll make it like 12 inches across, and let's make it 6 inches high. So last but not least, I have to do, just like I did with the circle, I have to create a notch in the bottom center, and so let's make that. I'll create a little rectangle, put it on there, make it 1/4 inch wide. Let's make it coincident with this line. Oop, no, I want to be in dimension mode. That coincident with this line, and let's make it all for construction. 1, 2, 3, 4 for construction, so that it won't hinder what I'm doing. And let's do some trimming. Let's trim away that and this. Okay, now we have cut away the bottom of the rectangle, and I think we're finally ready to do some lofting. So we'll finish the sketch. Now here I am with a circular feature and a rectangular feature. Let's do the go back into sheet metal. I'm going to do a lofted bend, and I'll do a lofted bend between here. Careful where you click. Try to make them similar spots. There's 1 and 2. Oh, I can see there's an error on my sketch. I'm leaving this in the video because you're going to run into similar things, and I want you to see that it's relatively easy to resolve. I'll go back into my sketch, and I'm going to make this top. Apparently it didn't get selected when I turned the other lines for construction, so I'll do that. Finish the sketch. Okay, now it appears that everything is proper. Let's try one more time. Go back into Lofted Bend. Click on this guy. Yep, now it's finally selected. Click on this one. And there is my lofted bend. I'll accept it. Let's actually choose the gauge though. I want it to be, say, a 16 gauge. So we'll select sample steel, the English, go to 16 gauge. I'll accept that, and takes a moment to calculate it, and here is my finished part. Now I can see that I've got a problem. Again, I'm leaving this in because I want you to be aware of things that can happen. Notice that my corners are not good. What did I forget to do? Well, I forgot to add a radii to the inside of that rectangle. Let's go back. Let's undo the lofted bend. Let's go back into the sketch, and let's add a corner fillet to each of the corners. We'll make it, say, a half-inch corner, a half-inch radii. Each corner. 1, 2, 3, yep, and 4. Notice I got a moment ago was that it's fighting this center line. I'm okay with that. It didn't damage it, and I'll accept that. Now let's do it one more time. Let's do a lofted bend. Go back to sheet metal. Oh, we got to finish our sketch. Lofted bend here and here, and now that I've added those corner fillets, it's a nice pure corner. The part looks good. It has the gap in the middle as I hoped it would. And there is my transition, my sheet metal transition. And just for demonstration, I will flatten it so you can see how the flat sheet metal would look prior to cutting and bending. And yes, it is flat, and there are my bend points. So that concludes this video. I hope you enjoy it, and good luck with your sheet metal.
Thank you for watching. This video is part of a series created by Neil Rosenberg and Joseph Caswell. All rights reserved.